Welcome to our Weights and Biases Keras integration webinar. I am your host, Charles Frye. I'm a deep learning educator at Weights and Biases. My job is to make material that helps people learn both deep learning and machine learning and how to use the Weights and Biases toolkit. Weights and Biases is an experiment tracking, data set versioning, model optimizing, and result presenting toolkit. It's a collection of modular separate tools that can be combined together, along with other modular tools that serve those purposes, to create reproducible, high quality, shareable machine learning research. I'm a researcher, so I think of research first, but this is also for things that go into production. So it doesn't necessarily have to be academic. What this Colab notebook covers is how to integrate weights and biases with your Keras code to add experiment tracking to your pipeline. That includes storing all the hyperparameters that configure your model in our config object. And then if you're using model.fit in Keras to train your models, then we've got a nice callback that integrates with Keras's callback system to log stuff that happens during training. And we automatically track a bunch of stuff like training metrics and system metrics, like how much your CPUs and GPUs are being used. We can't cover everything. This field moves fast and people try lots of different things. So you'll probably need to log some custom metrics. So we'll talk about using the wandb.log API to log custom metrics. All right, so let's get started. There's a nice little table of contents here on the side. And just to emphasize how easy weights and biases integration is, these things labeled step here are the parts that you actually need in order to instrument weights and biases in existing Keras code. The other parts here are the sorts of things that you would have already written, getting your data set, defining your model, defining your training logic, and we just slot right into that in just a few steps. To get started, some installs, some imports, and log into weights and biases. What we're doing in this cell is mostly importing stuff. One thing I did here is I want to make this as reproducible and as static as possible. I want to set the seeds of those pseudorandom number generators. So that's what I'm doing there with that set of hash commands in the last 3 lines in this cell. So this is something I recommend you doing as much as possible, sort of having control over the randomness in your pipeline so that you can make your experiments as reproducible as possible. If some weird phenomenon happens in one experiment and you want to track it down, see if there's a bug or if there's actually an interesting phenomenon going on, if you have the seed set, then you can do that. If you don't have the seed set and you can't recover the seeds, then you are up a creek without a paddle. Now it's time to install and import wandb. Right now, I'm pip installing wandb, regular installation command, nothing too fancy going on. You don't need Anaconda to link to binaries, anything like that. Now let's import wandb and log in. I'm going to open this guy in a different window so that y'all don't all end up with my API key. That's no good. That's a secret. There it is, completely secret. We got the API key added in. If you haven't signed in to wandb before, if you're not signed up, the link that pops up there, instead of just bringing up an API key, will give you an opportunity to sign up for the service. I recommend you do so if you haven't already. Now let's download and prep our data set. We're just downloading CFAR 10 from Alex Krzyzewski's website at the Toronto Computer Science Department's site. This is one of the fun things about machine learning being an academic field that grew really quickly. Some of the most important data sets in the world are hosted on a couple of universities' websites as .tar.gz files uploaded by graduate students. Right here, I'm shrinking down the data set so that this example will run a little bit more quickly. So I'm cutting it down by a factor of 5 with a little bit of slicing logic there. We haven't gotten really to the weights and biases code yet, and I want to get to that. So I won't spend too much time talking about this convolutional neural network here. If you want to learn more about this kind of stuff, check out our YouTube channel. We have some tutorial videos about defining convolutional neural networks in Keras, all done by our CEO and co-founder, Lucas Bewald, who's really just a delightful instructor. So I recommend you check that out. Now we're finally to the point where we're really starting to use the weights and biases library. The first thing we need to do is set up a run. One of our core abstractions is the idea of a run. A run is something that you want to log information about. The prototypical run is a machine learning training run where you take a model and you optimize its parameters. We're making our run here by calling wandb.init. We're giving it 2 arguments. One, we're setting the project that determines where it goes on your profile. It's sort of like setting a Git repo is the way I think of it. The other thing that we're giving is this dictionary, this config dictionary here. And this just includes all of our hyperparameters and metadata. So we've got a couple of things here, typical stuff that you treat as hyperparameters and maybe optimize over, like learning rate, epochs, batch size. There's also some metadata in here, stuff that you probably won't optimize over, but is maybe useful to keep around if you're looking back at an experiment and trying to remember what happened. What architecture was I thinking about at the time? What was the data set? The sort of stuff you'd put in a table of your experiments, maybe in an Excel document, Google Sheets on Google Drive. That kind of information, the metadata and the hyperparameters, we put them into a dictionary, give it to wandb.init, and now it's going to be visible as a config object. This is my preferred way of doing it. Set up a config dictionary that goes to wandb, and then after that, I only access all of my hyperparameters through that object. And that just ensures that whatever's logged online is also what is being used in my code. If I don't do that, if I just pass around, say, a dictionary like this one, that can mutate, that can change, that could introduce really subtle bugs, differences between what's being logged by WNB and what's actually being executed. To avoid that, we're going to use this config object. By default, we make sure that this thing doesn't mutate and throw an error if it does. We've got your back to make sure that nothing too crazy is happening. And now we're back to regular old Keras code. We just build our model, make sure it's on a nice clean slate with clear session. We're pulling up a little summary here. This is one of those nice Keras features that lets you see some stuff about your model. Let me execute this cell also so we can see it produce the results live. So wandb.init is going to produce all this information here that says things like, okay, who do we think you are? We keep track of versions to make sure that you know and we know, for reproducibility reasons, which version of our library is being run. We'll probably prod you if we've got a new version of our library with nice new features that you could benefit from. We save data locally before syncing it. If you want to check that out, you can find it with this one. We give your runs cute little names. Fanciful Meadow is the name of this one. The unique identifier is something that pops up in these URLs here. We give you two URLs in this output. One is the project page, the repository in which all your runs are being stored. And then there's a run page. For each run, we have a separate dashboard that you can check out. We'll go back to these pages in a bit. Right now, they're just sort of empty, waiting for us to start doing some machine learning. You're probably waiting for me to do some machine learning. So we'll skip over looking at this cute little description of our model and get down to model.fit. As I said before, we're hooking into Keras's callback system. That's down here. If you're not familiar with callbacks, the idea is you've got a bunch of hooks in the code that's being run by model.fit that say things like, on epoch end, run all the things that are associated with the end of an epoch. On batch end, defined moments at which other sections of Python code can be called. It calls back to some other code that was defined somewhere else. We have a callback that will do things like on epoch end, grab the loss, the accuracy, the validation loss, and the validation accuracy, and like take all of those and log them to our web service. So that you don't have to do anything on that front. If you're using model.fit, it's as easy as that. Everything else in this cell is the standard stuff you would do in using model.fit in the Keras API. The only difference is maybe that we're passing these hyperparameters as part of this config object, but I think that's also sort of best practice to have a config object with attributes. A lot of people use that as their practice for passing around these hyperparameters and metadata anyway. So the only difference is that it's our wandb.config that we've added a bunch of features to. Maybe I should have started running that code while I was describing it, because it takes a second to run even on a GPU. But yeah, so as this code is running, the network is training, and in the background, this information is getting logged to weights and biases. So I think I will actually just jump right in and show you what that looks like. As I said, we automatically log a bunch of stuff that model.fit is going to produce. We got accuracy, validation, accuracy, loss, and validation loss. We also keep track of epochs. If you want to keep track of other things like batch indices, we'll go through how to do things like that in a second. Then some things that maybe you wouldn't have logged if you weren't using our tool. We also log all these system metrics here. How much were you using the CPU? How much were you using, what was your memory usage profile? How much was I/O being used? Ever important, how well were you using your GPU? These are really useful metrics. I didn't used to log them. I tried to watch them myself while my runs were going sometimes to try and debug. But now weights and biases, without me having to do any extra tooling, will log this stuff so I can look at it afterwards. You can also watch your GPU heat up. That's fun. Watch all those bits get turned into entropy by the power of NVIDIA GPUs. We try and track your computational graphs if you're using PyTorch or TensorFlow. This is something that we pick up on. And then you can see parameter counts, output shapes, the things you'd see in model.summary in Keras. Those are all things that we log. We grab the standard output for you and keep track of that, just in case you need to look back and see what happened at some particular step. Maybe there was a NaN that popped up and you want to see what was happening around that time. We also track a bunch of stuff that Keras puts out. So this H5 file with the best model, we've got that. That's the weights and biases, literally, of this neural network model. Already we've gotten a lot out of the weights and biases integration, but this is a relatively simple one. We don't have a ton of extra media or files logged to show you. We got a lot of stuff, but you may actually want to log other things. Oh, I got a question here. How can I store the code or a pointer to the code that I use to generate a training run? This one is not configured to do code saving. You can set this up in your settings on weights and biases. On your profile, you can set logging of code. And for a Jupyter Notebook, what that actually means is we'll log the entire history of every cell that you ran in order, which is great because sometimes when you're really in the zone messing around with your models and tuning them, you might execute the cells in a strange order, end up with a result that might be hard to replicate. We'll store the code in the form of the session history and show that to you. That also works with .py files if you're running all of this in Python. So we'll save the .py file that you used. We don't have that on by default. The source code is often intellectual property, so we don't automatically scrape that for you without getting your permission. But it is something that you can do. So what I was saying was that there's a lot of things that we've already logged with weights and biases and that we've already been able to visualize and track. Sometimes there's other things that you want, right? Some people are pessimists, and rather than tracking their model's accuracy, they'd rather track their model's error rate. And that's not built into the model.fit. You're the kind of negatively oriented person who prefers test error rate to test accuracy. And maybe you want it in percentage points. Lots of people prefer percentage points to represent things like accuracy. Let's just log that. You can log whatever you want to weights and biases with wandb.log, and I mean that pretty dang literally. You log things as dictionaries. The key tells you what its name is, basically what column would this go under in a data frame of your runs. And then the value, what goes in that cell on the right-hand side of our colon here in this dictionary. That's how we use wandb.log to log custom stuff. You calculate it yourself, then log it. If you're a real Keras expert, maybe you write your own callback logic to do that. At the core of it, we're using Keras callback, so you can also hook into that system to do your own custom metric logging. Though, of course, there are also ways through the wandb callback to log additional stuff. So just check out our documentation before you go and implement stuff that we've already got a good version of. The last thing that we want to do is we want to indicate that our run is completed. There's a method .join that we call to indicate that a run is done. This is most important in a Jupyter Notebook context in which you might launch a whole bunch of runs. You really need to tell us, okay, this run is done. I'm not going to log any more stuff to it. Of course, you can reopen a run if you want, but it's like a file. If you open a file, it's polite to close the file explicitly later, even if you're going to need to open it again. So think of .join as file.close. Let's run this. Log the test error rate and run.join. We got some nice output here to let you know how that run went. So we already went and looked at it in the API, but some people like to stick to the CLI as much as possible, stick to the command line, or stick to their Jupyter Notebook. For that, we produced this nice little output here using spark lines so that you can see what happened to your values, like the loss went down over time, the accuracy went up. Just loosely, and also summary metrics. Our test error rate was actually a summary metric, just something that we log at the end. It gets put under our run summary here. This is not something that was tracked every step. This is something that we only checked at the end. Machine learning models break. They usually don't throw errors. They fail silently, extremely silently. It's almost impossible to know when your machine learning model is not doing what you were hoping it would do on your production data. There's been a lot of very high profile examples of machine learning models behaving badly. The only way to really know what your machine learning models are doing is to log, okay, what went in and what came out. Without an experiment tracking library, this would require writing a ton of extra code to log the inputs, log the outputs, and then visualize them. You're going to want a nice way to explore them. If you log 10,000 PNGs from CFAR10, how do I look through those? This is time that you're not spending, doing what you want to do, which is train machines to do cool stuff. In this section, we're going to demonstrate how to do this with wandb callback. All this stuff here is pretty much identical to what we did before. The only thing different is if there's a different learning rate and a different batch size. We're running a little ML experiment here to see how it goes. It looks really similar to normal, Keras code without wandb instrumented. And then here, we're going to pull out a small subset of images. We're just pulling out a subset because this is for, a human to look at. We're not going to log 10,000 PNGs because, it'd be hard for us to look through all of that. We're going to take this and we're going to pass this to wandb callback. And I think, it's a little bit the collab interface. I still am, I'm a basic Jupyter kind of girl. And so I haven't really mastered the collab interfaces, auto hinting stuff. Come on, show me the thing. Oh, there it is. You got to highlight behind parenthesis. This is the call signature for the wandb callback. There's lots of ways to configure it. We're going to focus on just one, which is solving this problem of how do I know what went into my model and what came out. Check out this documentation, look at the source code. You can see how to use all of these different things. What we're going to do is we're going to pass in some data using this training data keyword argument and the labels for the class names that correspond to each index. Also, we need to tell it that this is image data, so it knows to log it as an image. Callback is smart enough to know what you want out of this is you want to run the model on these images and check it against these labels, log that at the end of each epoch. While we're waiting for this to run, Lavanya's question was, when would you recommend using the callback versus using wandb.log? The callback is going to have relatively defined behavior that you can see from the documentation, and that will work for core use cases, labeling images, putting bounding boxes on images, doing semantic segmentation on images, tasks that are well known in the community. We have put in the work to make a nice behavior for our callbacks for the core machine learning libraries so that probably what you want to do is exactly what we're going to do. But sometimes you're doing something new and different. Maybe you want the images to be spun around before they get logged or something like that. So as you get to be more and more custom with your overall machine learning project, what you do with wandb is going to end up getting more custom. I think the nice thing is that we don't lock you into this callback. You can always go down to our lower level API. We've got a kind of layered setting of, okay, do I just want to use the callback with model.fit, or do I want to go all the way down to model.log? Do I want to go even lower down and use the wandb API to do stuff? We expose it to you and let you choose your own adventure there. So it's a matter of how custom you want to get. Other frameworks might not let you get that custom. They might lock you into their way of thinking of how things should be logged. So we try to be as unopinionated as possible about this. All we know is that you want to log stuff and we want to show it to you. But let's actually take a look at the results. This will be on the project page. That's the link that comes out when you run wandb.init. Let's go to that link. You can always go to your profile and find it from there. Let's take a look here. We still got the stuff that we had on the previous run here, but now we've also got these examples. So our model is not doing super great right now. We got a 40% accuracy, which is not so bad for 1 out of 10, but I'm pretty sure that is an ostrich and a goose right there, not a horse. It's certainly a bird of some kind, and that is a kitty. That is for sure a kitty and not a frog. We're not doing great right now. I will say, this bird here in the middle, it's green in the background, brown in the foreground. That is classic deer territory. This has got sky in the background. Obviously, birds appear in front of sky, whereas deer appear in front of trees. So our model has been learning something. Probably should run it for more epochs. Maybe we should give it more capacity. With this rich media output, we can see more than just accuracies going up, losses going down. We can see how the model is learning. I love the media logging stuff. I was always writing just like, matplotlib code to pull out predictions from my model and like plot images and try and arrange them. It was nice to learn some matplotlib and get practice with it, but it's not what I was getting my PhD in, I was getting my PhD in neural networks, not matplotlib. I was never going to implement something as nice as like, oh, look at that, it resizes as I change the size of this panel. Like that was beyond my grad student Python capacities. And would have been a waste of time to work on as well. Our weights and biases tool, we're about saving you some time. Hey friends, Charles here. Thanks for watching my video. If you enjoyed it, give it a like. If you want more weights and biases tutorial and demo content, subscribe to our channel. And if you got any questions, comments, ideas for future videos, leave a comment below. We'd love to hear from you.